Hello friends, this is my second live. So today we are going to discuss about machine learning without using a single line of a code. So there was a toolbox which have been just implemented by an Uber called as an Ludwig. So it is a toolbox which have been designed on the top of a TensorFlow. So which is going to design or which is going to allow you to make or design a model without writing a single line code. So this Uber toolbox have been made use of for just a commands. So these commands are going to just allow you to just make a input of your data. So after taking an input, so several commands are going to be just added, and finally we are going to predict it. So let's see what exactly this toolbox actually mean and where you are going to obtain the toolbox. Okay, so if you are going to search in an Google called GitHub Uber Ludwig, so this is a toolbox which have been available within 1 week back. It has been launched within 1 week back by an Uber people. So they have been just told that this toolbox have been designed on the top of a TensorFlow, which allows the user to train and test a deep learning models without need of writing any of the single line codes. So this is the some of the taglines which they have been provided, hashtags. So these are the files which have been just provided by this respective Uber toolbox. So in an introduction, they are going to just provide you a built-in toolbox, so which allows you to train and test a deep learning models without the need of writing any of a single code. So all you need is a CSV file, that is a data file, which is containing of your data, that too in a column wise. So in the first column you can have an input, and in the second column you can have an output classes. So by simply generating an CSV file and providing it to an Ludwig toolbox, so your job is fine, your job is over. So rest of the parameter decision, weights decisions will be carried out by this toolbox, and we can just considerably train the data set. So this toolbox is well efficient to predict a new data soon after finishing the training data set. So it have been provided with a programmatic API which have been provided by this toolbox. I'm going to tell about this API in the next few slides or next few minutes. So this is an API which have been provided. You can make use that API in your Python coding, and they have been providing various visual aids. So visual aids will be in the format of a graphs. You can analyze the training and testing efficiency. So they have been provided with a mindset of adding a new data sets, adding a new layer to the machine learning. So you can have a new model architectures, you can add a new data easily. So you can train and test the dupe, sorry, you can train and test the deep learning models as easily as it is. So it is very helpful for the researchers, students to understand what is deep learning models. So these are some of the features which have been provided. So there is no need of coding skills. So if you are afraid of coding, then this toolbox is a definite solution for learning your deep learning. So the next one is, if you are having a new data, you can make a number of models and you can make a prediction. And you are having a flexibility of adding a new models, building a training with a different learning capacity rates and all. So, and next one is, finally it is an open source, and this is a very much important thing. It is an open source. So let us understand how to install this respective toolbox. So in order to run this toolbox, we need all these libraries or packages which should be installed in your Python environment. So you need to install NumPy, Pandas, SciPy, Learn, Image, TensorFlow, Matplotlib, Python, H5PY. So these are all the some of the packages or dependency packages before installing this Ludwig toolbox. So you can install one by one, or you can use a single command called pip install. Ludvik. So this was all about the installation. So coming to an some of the requirements. So you will be having some of the requirements like while installing this Ludwig, they are going to have a requirement like TensorFlow should be above than 1.13.6 and the pip installation should be in 19.0 or something like this. So some of the requirements are there. So the system is going to take care of all these requirements by just by after typing this one, the system is going to take care of all the requirements. Pip install Ludwig. So the basic principle is you need to have a CSV data, that too in a column format. So this CSV data, by using the CSV data, we can have some of our definitions. You can make use of a RNN, CNN, any type of encoders for having a classifications or a image classifications or something like this. So these are the features which have been provided by this data types or a Ludwig toolbox. So binary classification providing two decisions whether true or false, numerical, categorical, some of a sequential based executions like having a set of a hidden layers as good as your TensorFlow. So it can also have a text classification. So if you are interested with having any sorts of live movie review based applications, you can go for these kinds of applications, time series, and finally a image classification. So one of the example have been shown here. So this is my data set or a data set what you are going to consider here. So this is a name of a column, that is doc text, and a name of a second column is class. So this is a input features and this is a output feature or an output class what you are going to just decided by the system. So one basic thing you need to remember here is whenever you are going to provide input features, so the column name here, it should be same as a name which have been provided in your input features. So this is a very much requirement you need to just understand here. So the name doc underscore text, it should be same while you are going to provide under an CSV file. So the commands are very much easier. Input features name. So the name of the column is dot text. So if the name of the column is features, you need to change here as dot text as features, and the type is text what you are using. So former president Barack Obama. So if this is like a text, the classes is politics. So the output feature is the name of the output feature is class. If you are having another different name here as an output classes or an decision making, you need to change this class from classes to an decision making if your column name is like decision making. So and that category is coming under an so that classes or the decision is coming under an category. So these are all the some of our definitions you need to just understand based on the training set. Based on the name of the column of your training set, you need to provide the same name while providing it to an model definition. So this is all about how you are going to take a CSV file. So then how you are going to train this. So you are going to train this model by using the small command here, ludwig.train, and this is a CSV file what you have been used. So you can just provide your own CSV files. It can be an sample CSV or it can be an some of our image data set which have been downloaded from the internet. Instead of a file.csv, you can provide your own links and you can just provide the data set for a Ludwig software or a toolbox. So after providing a CSV file, you need to define the model. So model means a sequential executions. So in this model, we are going to provide the information about encoders. So what does this encoders actually means that? So this toolbox is representing these kinds of a structure. So if you are having a text features or a category features, numerical or any type of input features, for every input you are having an one encoder. So after taking all the encoders, we are going to make use of a one combiner. We are going to suck all the informations from a input data set features and it is going to pass through the encoder. So in encoder, we are going to write about which type of no, CNN we are using or RNN we are using. So that is depending upon the user. So based on the encoder structure, so it is going to have a combiner. So after having a combiner, we are going to make use of a decoder. So this is just a flow for this respective toolbox. For every input features, we are having one encoder, and for every all other features will be combined with an one combiner. So after combining, we are having a decoder at an end. So all this will be decoded into an sum of information. So this is a general structure what you need to just understand here. So if you are after having a training sessions, okay, wait a second. The streaming quality is not good. Okay, let me continue. Okay, after finishing a training, you need to go for an prediction. So once this training is going to happen, so you need to have a prediction. So before that, I was speaking about this encoder. So in order to have this encoder, we can just provide some of our encoders here as RNN, CNN, or based on the some of our other encoders based on the applications. In order to understand this, you can go for an user guide. In a user guide, you are going to be provided with some category of encoders. So based on your applications, you can change those encoder styles. Okay, my internet low, I guess. So in a user guide, it is a step-by-step guiding provided to an user or an researchers. You are having how to train the data, how to predict the data, how to carry out the experiment, how to visualize. So visualize is the one what you are going to see here. So visualization of a data, model training, model validation. So how the training is going to vary with respect to your data set while predicting. So these kinds of facility will be provided by making use of a single line called Ludwig visualize. So here we are going to make a model training, model visualization or in validations. So based on this, we can understand what is the working or what is the efficiency of a work. So in an user guide, you can understand how to train, how to predict, how to carry out experiments, how to collect the weights or something like this. So here, so let me go to an API first. Okay, API have been opened here. So in an API, we are going to declare an Ludwig model. So inside a model, we are going to have a model definition. So inside a model definitions, we will be having a encoders like this. So inside an encoders, we will be having an RNN, CNN based on the applications. These things are going to be just varied. So why this model definition is, so it is similar to the dictionary, what you are going to use in your Python. So the collection of a data. So definition file, you can have a definition file as well. So instead of having a model definition, you can declare it in an YAML format and you can store somewhere, and you can also recollect it by using this model definition underscore file. So this logging level, it is used for logging, which is used for an debug sessions or while having any sorts of an errors or something like this. So this is a very first step. We are going to import it. The Ludwig model is going to be imported to your respective program. So after this, you are going to define. So now here you can define the model definitions. So the model definitions can be like this. So the model definitions includes like input features. So the name of your CSV file, that is the first column, it can be an doc test. So as I told you earlier, if the name of your column of a first column is dot text, you need to maintain a same name here. If the name is features, then you need to change in the name of in the position of this doc underscore text, you need to provide the name called feature, and the type is text. So you can just have all these lines in a model definition. So once you are going to define it, so you can just pass it to an Ludwig model. So rest thing will be taken sorry, will be taken care by this respective toolbox. Here you are going to train the data set by using a CSV file path. You can make use of your own CSV files, or you can make use of one of inbuilt CSV files which have been provided in the toolboxes. So you can just provide a link here. So it can be a sample CSV files or something like this. So after doing this, so this is a command which is used to train your respective model. Train Ludwig model dot train, and you are just passing a data set, that is a CSV file. So once the training is going to be just completed, so you can have a prediction. So once after having a training, you can have a predictions here. So predictions is given by Ludwig underscore model dot predict. So what you are going to pass here is your just your CSV file path. So rest things like hyperparameters choosing, weights classification, back propagations or something, all this weights, biases, dropouts, everything will be carried out by this Ludwig model. So there is no overhead for a user to take care of all this learning rates or any sorts of overfitting or underfitting, some issues like this. So finally, after doing a prediction, you are going to close the Ludwig model. So this is an API which have been provided. So in this toolbox, they have been provided an examples as well. So the very first one is text classification. If the text is in this format, you can just classify it as an earning. So in order to do these kinds of things, so this is a HAL based model definitions, as I've been told in the earlier. You can have a model definition in a single line like this, or you can go for this AL based definitions. You can define the models by making use of an extension called YAML. So this is the input features. Name is text, type is text, and encoder you can just make a RNN or parallel CNN or a CNN or something like this. So the output what you are obtaining or what you are expecting is just a name of a class, and it is based on the category. So the name of the class will be based on the number of features what you are going to be just trained. So if the data is closely relating to the statement like New York, or it can be in any sorts of other country, then it is going to just have a prediction that it has been belonging to an acquisition class. So in the same manner, if you are having any sorts of an affinity or an correlation with a uh, training data set based on the learning rate, so it is going to guess the classes of an output feature. So like this, you are having an n number of examples here. So my interesting is natural language understanding. I want pizza. If you are telling I want pizza, then the machine will